Okay, so we want to know whether exposure A causes the disease, as usual. So when we answer this question with a randomized controlled trial or an intervention study, what we do is first, as with all studies, we start with a defined study population. And since now we're not in the ideal world, we have many, many differences among the people within our study population. And so what we want to do is we want to create groups, one group which has the exposure and the other group that does not have the exposure, and then see which group is more likely to develop the disease. So what we do in a randomized controlled trial is we randomly allocate people to the exposed group versus the non-exposed group. So the randomization is the key aspect of a randomized controlled trial, and that's why it's called a randomized controlled trial. So we randomize people by flipping a coin or something like that. It's not really flipping a coin, but to our predefined groups. Okay, so one of the groups is exposed and one is not exposed. And so then, here are all the people, and so then the hope with a randomized controlled trial is that you now have groups that are equivalent, okay? They're equivalent in every way except the exposure, okay? So we haven't yet exposed them. They're sitting in their groups and they're waiting for the intervention, which will be the exposure, okay? But before the intervention, we can show that there should be approximately an equal number of men and women, people of different ages, people with different comorbidities, etc. So all of those things should be equal between the groups. And what's key about the randomization process is that it controls theoretically for unknown confounding variables. So as we saw before, the most important aspect of the study design in general, or a particular study, in determining and being good evidence for a causal relationship or a causal effect between an exposure and an outcome, is the extent to which you can isolate the exposure in one group. And so the comparison group or the not exposed group, you want to be exactly like your exposed group in every way except for the exposure. And so the randomized control trial is the best way of doing that because you can control for these unknown confounding variables. The unknown unknowns, as Donald Rumsfeld would say. Okay, so once you create these groups, you have two groups, the exposed or to be exposed and the not exposed, and they're equivalent. And so then what you do is you do your intervention, which is you expose the exposed group to the intervention. So you make sure that they have the exposure. So now your groups after your intervention are theoretically exactly the same except for the exposure, because you've controlled who gets the exposure and who doesn't get the exposure. And usually in a randomized controlled trial, the exposure is a treatment because you don't want to expose people to harmful factors in an experiment because you have lots of ethical issues. So usually you're trying to protect someone against disease in the case of a randomized controlled trial where you're intervening on people. Now, and then what you do is you follow the people. So everybody, of course, in your defined study population does not have the disease or the outcome yet. And so now you follow people. And so the question at the end is whether people with the exposure are more likely or less likely to get the disease than people without the exposure. Okay, so let's see how a cohort study is different from the randomized controlled trial. So with a cohort study, we're also asking the same question: does an exposure cause the disease? And again, we have a defined study population, and as was the case for the randomized controlled trial, the study population, of course, does not have the disease, because you're looking to see whether the disease arises in each group, so you don't want people who already have the disease. So, and again, we have a variety of things that differ among the people in our study population. Now, the difference here between the cohort study population and the RCT population is that the people in the study population have the exposure. So in the RCT, as we saw, the people are not exposed prior to the study, but in a cohort study, people are exposed already, just naturally in the natural world. And so what we do is we divide the participants from our study population into those who are exposed and those who are not exposed. Okay, so here we see that we've taken the people in our study population who are exposed and put them in the exposed group, and then those who were not exposed in the not exposed group. So this is called an observational study because the people who are exposed just happen to be exposed in the course of their existence. And so with a randomized controlled trial, it's not observational because you're actually intervening, you're creating the exposure. But in a cohort study and in a case control, you're just observing who naturally is exposed. So one of the issues with the cohort study is that in many cases, your exposed and not exposed groups differ in many ways that are other than the exposure. So what we want to see was, as we saw in the case of the randomized controlled trial, where the only difference between the two groups is the exposure, A. So everybody in the exposed group has A, and in the not exposed group does not have A, but otherwise there are no differences between the groups. But in a cohort study, because you're looking at how in its natural sort of evolutionary context, often there are many other factors that are correlated with A that are true of people who have A but are not true of people who do not have A. So in this case, we picked all the exposed people in our study population. Those people tended to also have B, C, and D, whereas the people that were not exposed, so didn't have A, didn't have B, C, and D, but instead they had E, F, G, and H. And so, so if your outcome looks like this, so the exposed group has a lot of disease of your particular outcome, and the not exposed group doesn't have a lot of the disease, so the disease is rare, you cannot just attribute the disease to A, because all these other things also differ between the exposed and not exposed. So because B, C, and D also differ, B, C, or D could be the cause of the increase in disease in this group rather than A. So B, C, and D, again, are considered confounding variables, as are E, F, G, and H. So any variables that confound the difference between the two groups. So anything that differs between the two groups that is not the key difference, which is the exposure, is considered a confounding variable. So cohort studies have problems with confounding variables simply because usually any exposure has multiple causes, and so to put people in a group based on a single factor, a single exposure, you're going to end up pulling along with that exposure, all the other things that are correlated with the exposure that lead to the exposure in one group as opposed to another. So for example, smoking cigarettes in one, if that's your exposure, at least in today's society, smoking cigarettes is associated with income and education level, maybe even gender in some situations. And so if you're going to pull people who naturally smoke, and put them into one group, you're going to end up with people who have a lower income. So you have to be very careful and make sure your control group matches your exposure group on those other dimensions. So you'd have to pull a lower income group of people to compare with your exposed group. So we're going to talk about later how to deal with confounding variables, but you can see that it's important, and cohort studies are less able to deal with confounding variables than our randomized controlled trials. And one last point before I end this video, I should mention that in order for a variable to be a confounding variable, it has to be related to both the exposure and to the disease. So the problem is that a lot of times you don't really know whether it's related to the disease, but if it's something like, people were born on a certain, the first 6 months of the year in one group versus the second 6 months in the other, and you think that would have nothing to do with the disease, then you don't have to consider that a confounding variable. But we'll talk more about that later, and I will end this video since it's getting long.